The crane, however, was not always as we know it today. Since prehistoric times, people have had the desire to move things. But the objects people have wished to move have sometimes been too large. Of course, ancient civilizations didn't have the sophisticated technology of modern days to calculate forces, moments, weights, and all other related physical properties of the crane. The Romans and Assyrians used a primitive version of a crane to move objects that were too large for human muscles. Cranes of this time, 100 AD, still required human effort as a power source. Notice the application of a treadmill. The variety of materials used in construction, as always, was limited by the technology of the time. This crane, in operation some 1,300 years after the Roman crane, still uses timber construction with the treadmill as its motive force. Even up to the beginning of the current century, the lack of a light and efficient power source led to some cranes being hand-powered. This example is shown in use on the Great Zigzag in 1908. The development of the crane from those early days has followed the same basic trend. It has always been a compromise between the job the crane was required to do, the materials, and the power source available. In the early 1800s, new power sources and higher strength materials became available. The steam-powered crane of 1879 is typical of this development. Heavy, rail-mobile, steam-powered cranes of large capacity were developed for use in shipyards and other heavy engineering application, including railways. Note the solid construction of this 75-ton crane. The development of the internal combustion engine was a very significant move and an early factor in the size and weight reduction that led to greater crane mobility. As stronger and lighter materials were developed, the crane in turn became still lighter and therefore more suitable for mounting on a truck chassis. It was in this period, early 20th century, that the mobile crane as we know it today originated. The application of electrics, petroleum-driven motors and structural steels developed new trends in crane construction. The first self-propelled, truly mobile crane appeared in 1932. What an innovation! A crane that could travel under its own power in any direction. Within a few short years, there followed a crane that could travel under its own power at 10 kilometers per hour. A definite improvement on the cranes which were in use only a few years previously. Development continued and resulted in this crane, capable of lifting 5 tons. With mass production techniques to reduce the price, cranes found wider use in industry. This accelerated experimentation with new materials. By 1950, the first truck crane, capable of lifting 20 tons, evolved. Gradually, the crane was becoming a far more useful machine. It was used widely in building, shipping, and on manufacturing sites. It could move under its own power and it was lifting ever-increasing loads. Just 13 years later, mobile crane capacity had broken the 100-ton barrier. While this great increase in lifting capacity was being achieved, other advances were also occurring. With greater building activity, a more versatile crane was required. This 1966 crane is an improved development of the telescopic concept, capable of lifting 12 tons. To this stage, mobile cranes had been developed along fairly general lines and designed to handle a number of different but related tasks. For these two cranes, note the solution to mobility over difficult terrain, tractor tyres and crawler tracks. One of the first special-purpose mobile cranes was designed specifically to handle the United States government intercontinental ballistic missiles. Special-purpose cranes are a rare sight because the more jobs a machine can do, the more economically it can be used. Can you think of a more everyday example? Yes, a special-purpose crane is one that is designed to lift pallets of bricks. A most important recent development in crane technology has been the use of high-tensile steel. This can be seen in the slender design of this jib. The use of stronger steel meant that lighter weight cranes could be relied upon to lift loads of 80 tons and perhaps more.